So in these notes we're going to be looking at the last solid of the solids unit, and that's spheres, and then we're going to take some of the solids and put them together for compositions, otherwise also known as combinations of solids, and then we'll do a little bit more with working backwards. So let's start with what a sphere is. So a sphere is, sorry, that pencil didn't work. Okay, so a sphere is basically a ball. Okay, and by the way, if you're coming to Monday's Google Meet session, I'm going to do I'm going to go right through these notes. So if you're planning on attending that session, you can stop the video and wait for our session. Okay. Okay. So notice how I made a big circle, and then I put basically the equator on that big circle. I'll put the center right in the center of it, right there. Okay. So a sphere is basically a ball, right? And you can see it's rounded in 3 dimensions. Okay. A radius can be drawn on it, and a radius can go in any direction. So it could be kind of going up like this. Right, this is a radius, but I could have put the radius going across here or straight up. Right, doesn't matter. Okay. So there isn't really a height for this solid because there's not really a base. So it's important to note that there's no bases and no faces for this. Okay. Right. If we think about the height, right, I'm gonna put it in quotes because it's not really the height, but if you want to say how tall is the sphere, well, the height would go from down here to up here. How tall is the sphere? Well, that would just be your diameter, because it go from the very bottom to the very top, right? And that would be your diameter. Okay. So you can see that this one's set up a little bit different just because it doesn't have any faces. Turn that on, maybe that's going to help my camera. Okay. So there's our basics of what the sphere looks like. Okay, so why is there no lateral surface area of a sphere? And it's because there's no bases. Or faces for that matter. Okay, so you can't have lateral faces if there's no faces at all. What's the equation for the surface area of a sphere? Okay, and so with this one, you know, we saw with other ones that you could break it up into shapes you can work with. You can't really do that with a sphere, right? The surface area is 4 pi r squared. Okay, so you can see that it has the pi r squared, the area of a circle formula, and there's just 4 of them, right? So you know, if you had 4 circles with this radius, you could just wrap it all around there, and but it's really no great way to see that. Okay. And some of the other ones we've been talking about, like drawing nets for this one, you can't really draw a net as we do it, because and you know, surface area comes from drawing that net, right? Your net for this kind of would look like this. If you think about it, like when you were to peel an orange and you let that orange peel flat, there's no great way to do it. So, but if you think of it like you slice it, almost like I think of the world map. Okay, if I slice it, this is what the net would look like. And I'm never going to ask you to draw it, but I just want to show you, like, right, it kind of looks like if you had orange slices and unpeeled those orange slices, right, all of them lined together for however many orange slices you cut. Okay, and the reason the net's so hard to draw is the reason that the world map is so messed up is because that net is so hard to draw. Like if you ever see a map, you can see that Greenland is way too big for the map compared to what its regular size is. Antarctica looks absolutely massive because they fill in all this space, and it gets messed up. So to make a perfect world map, you'd have it look like that, but that'd be kind of hard to follow. Okay, so what is the equation for the volume of the sphere? So again, there's no great way to see this. So, you know, I can't use the sugar or the models or anything. I'm going to get 4 pi r cubed for that one. Okay, so those are my two equations, and you never need to memorize those, right? When you take your solids unit assessment, you can just make a little formula sheet for yourself or whatever to help you, right? Or you can look back at your notes. Okay, so if I'm going to find the surface area and volume of each sphere, then okay, so the radius here is 4. You can see the radius in this case is just left to right, so I just take that formula and I just plug in where the radius was. I plug in 4, so it's going to be 4 squared, which is 16, times 4, so it's 64 pi. If there's units on this, then I'll put square units here. There weren't any units, so I'll leave it off. If I'm doing volume, I have 4/3 pi r cubed. 4 to the third is 64, times 4 is 256, divided by 3. It doesn't divide by 3. So, and I know that because that number's 4, and 4 is not divisible by 3, so there's no way that 4 cubed is going to be divisible by 3. Okay? And that's a great way to leave your answer. If you want to put it as a decimal that's repeating, that's fine. Do not multiply through the pi though, right? You could have said, okay, what's 256 divided by 3? Let's see, that's going to be okay, let me just double check that. Yeah, you could have written it that way. I just don't like that because it has a repeating symbol, so you're going to see me write it this way. You see our answer key showing that when you check your work. This one's going to be the same exact thing. It's just you're plugging 8 in there for yourself. So it's really, once you do one, right, they become all the same thing. So let's find the volume of each solid. Okay, so if I'm looking at this solid here, I know it's really large. I couldn't scale it very well, so I had to leave these large. So if I look at it, to find the volume, we're only going to do volume for this. If we were in class, actually in class, we'd do some surface area for it, but we're just going to do volume for these. And so the volume of each solid, okay, so if I look at this, this on top here is going to be a hemisphere. Okay, and what's underneath here is going to be a cylinder. Okay, and so we have those two. So, okay, a hemisphere, okay, that's half of a sphere. Okay, and again we're doing volume, so I know how to find the volume of a sphere. It's 4/3 pi r cubed. Okay, but I need half of it, so I'm going to multiply it by half. Because there's only the top part of it, not the bottom. I can see what the radius is, so I'll plug that in. Okay, so I'll use my calculator. I'll do the 4 cubed is 64. How about I cut that in half? Right, 64 cut in half is going to be 32. 32 times 4, 126. Okay, and then we divide. It can't be divided by 3, so I'll just leave it that way. So that's the volume of the hemisphere. Let's think about the volume of the cylinder. Okay, we think back. It's area of the base times height. What's the area of the base? Okay, well, the base. Well, you have to figure out the radius of it. It's a circle, and so let me draw that radius in for myself. And first you might say, oh, the radius isn't given. It has to be given. It has to be there somewhere, and it might be hidden. It's up here. If the radius of this is 4, well, that must be the radius of this as well, because it's just because they're stacked on each other. Whatever this radius, whatever the hemisphere is a radius of, that's going to be the same for the cylinder. Okay. Well, if that radius is 4, then finish off my circle information. My area is 16 pi. the height is given as 12. So I can just do 16 times 12. 192 pi. Okay, and now I can add those two together. Now that's not the easiest thing to add together, so this might be a time when you're like, oh, maybe I prefer the decimal version of that. In this case, oh, actually it divided. I messed up on something. That wasn't 126, that was 128. Should have checked my work. So it's 128 divided by 3. So that's 42.6 repeating pi. And if I add that to this, right, that shouldn't be too hard because I'm just adding my two numbers. Okay. So I'm basically taking the volume of my hemisphere plus the volume of the cylinder, right? Add these two. Right, and that gives us that number right there. Okay. If there's three pieces that make it up, you add it. You find all the volume of all three, and you add them together, right, for yourself. So you just kind of break it up. It's just this problem is basically just two problems put together, two problems in one, and you just find the volume of each one. Okay. So for this one, if you're going to do it, remember that this is a hemisphere again, and that's a cone. Now this one I think is a little bit harder, right? I'm not going to do the whole thing. I'm just going to make sure that you can do it on your own. Okay, we've got the hemisphere on top and we have a cone on the bottom. Remember that for the cone, the volume is area of the base times height divided by 3. We can see that the radius for it is 6, and I'm going to draw it right in here. We can see the slant height is 10, but we can't see what the actual height is. And let me use a different color so it really jumps out at me. Here's my regular height. The height of the cone is right here. Okay, and then there's my radius. Okay. So for this one, we're going to have to find that regular height. So look at you can see that we have this triangle right here. This triangle right here. And now we're back to, hey, how do we find the height of our cone? And you may or may not remember from that when we just did cones last week, hey, I can use there's a right triangle, I can use Pythagorean theorem or triples to help me get this height. Okay, and that's how you get this height of 8. Right? 6, 8, 10 is a Pythagorean triple. We use that. Now we have the height. Now we can find the volume there. And you can finish that one up from there, right? And then check my answers. Or check your answer against mine.